Our next section is dividing monomials and polynomials. Polynomials, more than one term. So things like 2x squared minus 5x plus 8 is an example of a polynomial. It's really just a bunch of monomials connected with addition or subtraction. So we want to simplify these. We want to divide. Yesterday we multiplied, today we divide. Let's see what to do. Replace the triangles with the correct exponents. Oh boy, well let's see. If I'm counting x's on the top, 1, 2, 3, 4, 5, 6, 7 x's on top and 4 on the bottom. And if I remember some things about division, is I can cancel some of these terms. I can cancel common factors. So what's left then is x to the third. So that upward triangle is 3. That was x to the 7th. On the bottom was x to the 4th. And I get a triangle value of 3. And if I think the same way, I have 9 6's across the top and 4 6's on the bottom. 4 of those will cancel 4 of the 9 up top, leaving 6 to the 5th. So my down triangle is 5. All right, I think I'm getting an idea about what to do here. I think I'm getting something. Okay, Emma's got more work to do. 5 to the 24th, which means 24 5's written across the top, divided by 5 to the 8th. And we want to simplify that. Well, let's see. If we have 24 5's on top, I can cancel 8 of those on top with the 8 on the bottom. And I'm going to get 16 of them left. So my answer should be 5 to the 16th. Okay, so now let's think about what's going on here. How am I getting 16 from a 24 and an 8? How did I get some of those values before? I got a 3 from a 7 and a 4. I got a 5 from a 9 and a 4. So I have 12 of them on top, 5 on the bottom, or down here now, I have 4 to the 12th divided by 4 to the 5th. Let's see. I can cancel 5 of those on the bottom with 5 of the 12 on top, and that'd be 7 left over. So what am I doing to 12 and 5 to get 7? What am I doing to 14 and 10 to get 4? Yeah, I'm subtracting. So do we think that we want to subtract the exponents here? That would make sense. Hey, think yesterday. When we multiplied, we added exponents. Should it make sense that if we do the inverse of multiplication, we have to do the inverse of addition? I think we got a rule. So in dividing monomials by the same base, again, we're going to keep the base. And let's subtract exponents. Keep the base and subtract the exponents. That's our plan for today. All right, let's put that into play. Oh, that's an interesting problem. What is the value of 5 to the 7th divided by 5 to the 7th? Well, let's see. I get the same number on top and bottom, right? So that answer should be 1. And same thing, whatever C is going to equal, I got the same thing on top and bottom. It should be 1. So yes, so when you divide a number by itself, you get 1. That makes sense. But what about doing that common base rule now? 5 to the 7th divided by 5 to the 7th. If we do that rule we just learned, shouldn't we get 5 to the 7 minus 7 or 5 to the 0? Can you have an exponent of 0? And on the bottom one too? C to the 0 power? Well, if originally up top I said 5 to the 7th divided by 5 to the 7th, and that was 1, and then if I subtract to get 5 to the 0th, should it make sense if 5 to the 0 power equals 1? And as a matter of fact, anything to the 0 power should be 1? Yeah. So any value whose exponent is 0 is equal to 1. Check it on your calculator. All right, so far so good. That's a neat little trick. So we got two things so far. When we divide these monomials, we subtract exponents. And if we get an exponent of 0, the expression has a value of 1. Okay. Oh no, we have a polynomial on top. We got 3 different terms. But how come 5x to the third plus 15x squared plus 25x, all that divided by 5x can be thought of as 3 dividing monomial problems? Well, isn't just like 5x to the third over 5x plus 15x squared over 5x plus 25x over 5x? Isn't just those 3 together? So now let's evaluate those 3 problems. The first one, 5 divided by 5 is 1. And now let's subtract those x's. I'm going to put my exponent of 1 on bottom. So I get 1x squared. 15 divided by 5 is 3. I have 2 x's on top. I have 1 on the bottom. When they cancel, I'm left with 1 on top. 25 divided by 5 is 5. I have 1x on top, 1 on the bottom. There's that x to the 0 again. Hey, but what's x to the 0 equal to? 1, that's right. So this is really 5 times 1, or just 5. And I'll bring down that 3x, and I'll bring down that x squared. And I have addition signs between them. Yes, so really what we can think of, if I go back to the original problem, is I could just divide 5x by each of those problems. It reminds me of the days when I used to be a cowboy. And I make a cowboy hat. Oh, what a great way to remember it. Okay, so let's keep going a little bit. Can we simplify those two? Well, if I make that little cowboy hat there for a minute, I can do negative 10 divided by 2, which is negative 5. And I still have the x squared term there. I can do 8x divided by 2, which is a 4x. And negative 6 divided by 2, which is negative 3. And for the last one as well. If I divide those, let's see, 21 divided by 7 is 3. And then I have 4 x's on top and 1 on the bottom. So if I do that subtraction, I get x to the third. If I do that middle one, or the second term, 14 divided by 7 is positive 2. I have 3 x's on top, 1 on bottom. That's going to leave me x squared. Negative 7 divided by 7 is negative 1. 2 x's on top, 1 on the bottom. So I get 1x. And yeah, you're right. I can just write that as negative x. But here's why I did that to begin with. Take a look at the last one. 7 divided by 7 is 1. X to the first, and x to the first gives me x to the 0. But you remember again what x to the 0 power is. Remember, x to the 0 is equal to 1. Anything to the 0 is equal to 1. So then this final answer is going to be 3x to the third plus 2x squared minus x plus 1. Please don't just cross those x's off, or the 7's at the end too. A lot of people want to just try to get a 0 here for this last term. You don't want to do that. All right, let's wrap things up. We did a lot of good things over the last 2 videos. When we multiply monomials, we keep the base and we add exponents. Monomials to a power. Keep the base. And multiply exponents. And the new one for today, when dividing monomials, you got it right. We're going to keep that base. And we're going to subtract the exponents. So dividing is that new rule for the day. But as you can kind of see, they're all connected. Thanks for watching. See you soon.